Welcome to Unit 4. This is triangle congruency. So being able to prove that two triangles are congruent to each other. We talked a little bit about this with rigid motions in Unit 3, but we're going to go into more depth with it and be more specific. And we're going to focus on some vocab today and relating some things to what we did in Unit 3. First thing we want to talk about is the reflexive property. So that is when a number, which could be a side or an angle in our case, so the length of a side or an angle is always equal to itself, which sounds self-explanatory. But the reason we need to know that is because we need to be able to label different parts of triangles that are congruent to each other. So, for example, on the left diagram, we have two triangles, but they're overlapped. So we have this yellow triangle, and we have this blue triangle. But up here, where it's green, is overlapping because that angle up there is shared by both triangles. It's a part of the blue triangle and it's also part of the green triangle. So because it's literally overlapped on top of itself, it has to be congruent. So that means there's one set of angles we could automatically say is congruent within the triangles because it's shared, it's overlapped. So we could say that angle G is congruent to angle G because of reflexive. Then sometimes when triangles overlap, they overlap on a side. So I'm going to do the highlighting again. We have the yellow triangle here, and then we have the blue triangle. Since blue and yellow make green, the part where they overlap is the green part. So that means that that side is shared by both of them. And it's congruent to itself because it's overlapped on top of itself. So what we can say about this one is that BC is congruent to BC because it's reflexive. Sometimes you might see BC and CB either way, because remember, you can name this side BC or CB, either one. And that would be one corresponding set of sides between the triangles that's congruent. And that won't be enough to prove the whole triangles are congruent, but we'll eventually learn how we could prove more sets of sides or angles are congruent. That would just be one step in eventually trying to show that the triangles are congruent. Then another way to get congruent angles is bringing back vertical angles. So we're still going to be using those. So remember, if you have angles that are across from each other, sharing the same lines that intersect, they are going to be congruent. So just by looking at this picture, we can come up with a set of congruent angles. So that would be, remember, a vertical is like a V touching another V. So that would mean that this angle is congruent to that angle. They're always congruent. So we would name that with 3 letters. So we have PNO is congruent to, we could do MNL because they are vertical. Vertical angles are congruent. So these three are just, or these 2 properties basically, are examples of things you can find within 2 triangles that are congruent to each other without having to have a given or it's a property by looking at it. So it's something you can figure out by looking at the diagrams. All right, now we're going to practice talking about different things that are congruent within the diagrams. So the first thing we look at are the markings. So this has a tick mark here and this has a tick mark here. So we can say that from the red ones, AD is congruent to CB. Then we also see congruent angles. So we would have to name that with 3 letters. So we make sure for on this one, it's on the left side, so we're using those left points, but B has to be in the middle because that's where the vertex is. So angle A, B, D. And then over here, you would need D to be in the middle because that's where the vertex is, and we have to use these letters because it's on this side, on this triangle. So C, D, B. Then the third thing comes from what we learned in the previous one, and that's the reflexive property. So if you notice, this green line segment is shared by both triangles. It's overlapping, so it's congruent to itself. So I could put in 2 markings to show it's congruent to itself. And I can't use 1 because we already have 1 used over there. So you would say DB. And since this is rotated, like it's not just flipped over, it's rotated, D ends up where B is and B ends up where D is. Technically, you should write it this way to show that it was it was rotated and the order changed when it rotated over. Then for this next one, we can start with this congruent marking, the 1, and you would say BC is congruent to DC. And that was given to us. So something to note from here, and the reason for this green one was because of reflexive property. So, and then these 2 are given to us in the diagram. BC congruent to DC, that was given to us in the diagram. And the next one, the 2 congruent markings would be AC congruent to EC, and that was given to us. And then something we can get by looking at the picture is this angle congruent to this angle. So we add it in and then we write it down. And it's vertical angles. You need to make sure you name it with 3 letters. So B angle BCA is congruent to angle DCE. And the reason we know that is because they are vertical. So we're doing this as practice to eventually be able to name things enough to show that the actual triangles are congruent. So we're just setting up, preparing until we are ready for that. Okay, so in order for triangles to be congruent, all the sets, of course, or all the angles and all the sides need to match up. So there needs to be a side on this triangle that matches up and is congruent to a side on this one. And then all the angles also need to match up. So what that means is corresponding parts of congruent triangles are congruent. So sometimes like in the SAT or something, you might see it, the acronym CPCTC. We're not going to use it because every year we use it, people don't know what it stands for. So we're going to talk about the fact that corresponding parts of congruent triangles are congruent and use that wording instead of using an acronym because people forget what the acronym means. So we're going to match up. If I told you that these were congruent triangles, we can match up every angle here with an angle here and every side here with a side here. So angle A is going to be congruent to angle F. Then C, it's different, so we need to put 2 markings, is going to go and be corresponding with E, and that's going to be congruent. Oh, I skipped one, sorry. Went out of alphabetical order. Then angle B is going to be congruent to angle D, and then we'll do the sides. So AB will give 1 marking, and that goes with FD. And then AC goes with, oops, I'm going to follow along here. BC would be this one, and that goes with DE. So they both get 2 congruent markings. And then CA goes with EF. And then we need to put the triangle in the right order. So every set of angles and sides are congruent. We can match every angle up here with every angle here, and every side here with a side over here. So that since every corresponding part is congruent, we can say the actual triangles are congruent. You would be able to take this one, move it over, and fit it perfectly on here. Specifically, it would be a translation because you could just slide it over, and they would fit perfectly on top of each other, and they would be congruent. But we have to put them in the right order. So A is congruent to F, so then we need to put an F here. B is congruent to D, so D would have to go next. And then C goes with E, so then E would go next. So triangle ABC is congruent to triangle FDE. They're in the same order. All the corresponding parts have to be in the right position. So let's talk about how this relates to rigid motions and transformations. So the 3 rigid motions were translation, rotation, reflection. Remember that meant that it kept the triangles congruent to each other. The one non-rigid motion that was a transformation was that dilation, and it breaks congruency because one's going to end up smaller than the other. So we could use those transformations to show, like, if it was a translation, rotation, or reflection, that means that the triangles are going to be congruent. If it was a dilation, they're not. And that would mean that all corresponding parts or all corresponding sides and angles would have to be congruent. So here's an example. So we have triangle ABC, and we have this triangle over here, ZXY. So what transformation has occurred? It was rotation 180 degrees. And that's a rigid motion. So yes, the triangles are congruent. Triangle ABC. I ran out of room. So yes, triangle ABC. Now we got to match things up. So A has 1 marking, so that means Z would go first. And then B has 2 markings, so then X would go next. And then C doesn't have any, so that would go with Y. And then it wants to know what would be the corresponding part to BC. So since the triangles are congruent, we could also say other things are congruent. So right now only 3 things were marked, but we're saying that we know it's a transformation of a rotation, it's a rigid motion, so the triangles have to be congruent. So because the triangles are congruent, all the sides and all the angles are going to be congruent. So we want to know which one goes with BC. So the one that corresponds to BC, so since it was rotated, this was on the left and it rotates 180 degrees, it comes over here. So the one that goes with BC is XY, and you could also look at it here. So B goes with X and C goes with Y. So the next one, we're trying to decide what transformation has occurred, and if that's a rigid motion, and therefore we can show it's a certain, it's congruent triangles. So we have this has 2 congruency markings, and this has 2, so it moves over there, and then this one moves over there, but these congruent angles stay on top. So you should see that it's a reflection over the y-axis. So this is a reflection. I can't spell. Over the y-axis. Yes, they are congruent. So triangle, and we need to name them in the right order. So we're going to start with A, and then B, C. It doesn't matter the order of the first one. You just need to make sure you match up everything in the correct order with the second one. So since A reflects over here for X, we know that A and X go together. Then B reflects over to Z, so Z corresponds with B, and then C reflects and comes over to Y, so triangle ABC can grow to triangle XZY. And then it wants to know, so then because of that, all of the corresponding other angles and sides are congruent too, even though they're not marked, because we said the triangles are congruent. So A is congruent to angle X because A is in the first position and X is in the first position. And since we have congruent triangles, we have congruent corresponding angles. Then the next one, if we started with triangle ABC and then ended up with the blue triangle, this is a dilation. So the triangles are not congruent. And we can't do this part because the triangles are not congruent. So if you have congruent triangles, then all the corresponding sides and angles are congruent. But in this case, it's only the angles. So even though all the corresponding angles are congruent, that doesn't necessarily mean that all the corresponding sides are too. It would have to be all of it. So since we just had congruent angles and there weren't any congruent sides, that happens with a dilation. We do not have congruent triangles. So only the rigid motions of translation, rotation, reflection. So this one was a reflection, this one was a rotation, and then this one was a translation. Those all create congruent triangles, but not the dilation. Make sure you do your practice.